Good day, Ma'am Rachelyn Fernandez. I am Mark Jestony B. Good of BECE 1C. I am here to present my answers and its explanation of our fourth assignment in ES 14 Calculus 2. My answer sheet will be placed somewhere right here to have a clear visual aid. In our assignment, we are assigned to evaluate the given improper integrals. So, in number 1, I am tasked to evaluate the integral of lower limit of 1 of the upper limit of infinity x cosine x squared dx. So, firstly, I have to determine what formula to be used. In this case, I will use the case number 1 because it is the appropriate formula for in this equation. So, let's apply. So, the limit of integral of lower limit of 1 upper limit of b x cosine x squared dx, where b is approaching to infinity. So to apply the integral of lower limit of 1 to upper limit of b x cosine x squared dx, so let u equals to x squared, du equals 2x dx. So to remain the x dx, we have to divide 2 in both sides. So we have now the du over 2 equals to dx. So let's plug in the substitution. So we have the integral of cosine u over 2 du. Let the 1/2 out of the integral. So we have 1/2 integral of cosine u du. Then integral of cosine u du is sine u. And we have now the 1/2 times sine u. And let's substitute back the value of u, and now we have 1/2 sine x squared. Next is to apply the lower limit and the upper limit. So we have sine b squared over 2 minus sine 1 squared over 2, and that is equals to sine b squared minus sine 1 over 2. So that is the just for simplification. So we will find the limit of sine b squared minus sine 1 over 2, where b is approaching to positive infinity. So we have the limit of sine b squared over 2, b is approaching to infinity, minus limit of sine 1 over 2, where b is approaching to infinity. So we have negative 1 over 2, or 1/2 minus sine 1 over 2, or in any form, in other form, we have negative 1/2 minus sine 1 over 2, 1/2 minus sine 1 over 2. So this is divergent because while the b is approaching to positive and until it becomes 0, so whether how large the number of you apply in b, so it will only be result in negative 1/2 or 1/2. So this is divergent because the limit of the integral does not exist infinite number or infinite number. Now in number 2, I am asked to evaluate the integral of lower limit of negative infinity, upper limit of 1 for e 3 ln x dx. So firstly, we have to identify first what formula to be used. And in this case, we have to use the case number 2 because that is the appropriate one to applied in this equation. So now, to apply the formula, we have the limit of integral of 1, limit of integral of lower limit of a, upper limit of 1 for e 3 ln x dx, with where a is approaching to negative infinity. So we have now to find first the integral before anything else. We have to find the integral of 4e 3 ln x dx. So let u e ln x ln x, and it is also the equivalent of x. So du, the derivative of u, of course, the derivative of x is 1. So 1 and dx, or dx only. Let's substitute the u and the du. So let's keep out the constant 4. So 4 integral of u to the power of 3 du, and that is equals to 4 into the integral of x to the 3 dx. So the integral of x to the power of 3 dx is 4x. 3 plus 1 over 3 plus 1 is equals 4 times x to the 4 over 4, and canceled out the 4. And we are now left with x4. So we have to find or evaluate the lower limit and the upper limit of x to the power of 4. So that is equals to 1 to the power of 4 minus a to the power of 4. So the limit of 1 minus a to the power of 4, where a is approaching to negative infinity, we have the limit of 1, a is approaching to negative infinity, minus limit of a to the power of 4, where a is approaching to negative infinity. So we have the result of 1 minus infinity. So of course that is equals to negative infinity. And we have, and as the result being shown, we see that there is no finite number or a finite value of this integral. So this is divergent because the limit of the integral does not exist infinite number. Last but not the least, number 3. In number 3, I am asked to evaluate the integral of lower limit of 1 with the upper limit of infinity. 28x to the power of 6 plus 7, 4x to the power of 7 plus 7x plus 2 to the power of 4 dx. So again, firstly, I have to determine what formula to be used. So like in number 1, in this case, I have to use case number 1 because that is the appropriate one in this equation. To apply, we have the limit of integral of lower limit of 1, upper limit of b, 28x to the power of 6 plus 7, 4x to the power of 7, 7x plus 2 to the power of 4 dx, where b is approaching to 8. So let's find the integral of the equation. Let u equals to 4x to the power of 7 plus 7x plus 2, and the integral of u, that is du, is equals to 28x to the power of 6 plus 7 dx. To remain x, let's divide both sides, 28x to the power of 6 plus 7, so that we can cancel out the 28x to the power of 6 plus 7 and remain dx, and we have the du over 28x to the power of 6 plus 7 equals dx. So let's apply the u and the du in our equation. So the integral of 28x to the power of 6 plus 7 used to the power of 4 over 28x to the power of 6 plus 7 du. So then canceled out the 28x to the power of 6 plus 7. So and we have left with integral of u to the power of 4 du. So the integral of u to the power of 4 du is, of course, u to the power of, using the power formula, we come up to the result of u to the power of 5 over 5. So and then again we have to evaluate right now the lower limit and the upper limit of this. So before that, we have to substitute back the value of u. So we have 4x to the power of 7 plus 7x plus 2 to the power of 5 over 5 with the lower limit of 1 with the upper limit of 5. So in calculating, we come up to the result of 4b to the power of 7 plus 7b plus 2 over 5, the power of 5 over 5 minus 371,293 over 5. So let's find the limit of 4b to the power of 7 plus 7b plus 2 over 5 minus 371,293 over 5, where b is approaching to positive infinity. So we come as the result, we have the answer of positive infinity. This is a divergent because the limit of the integral does not exist, or this is the infinite number. That will be all, and I thank you. Again, this is Mark Justini B. Good of BEC 1C. Stay safe and be happy always. Thank you.